Today I'm going to be solving systems of equations using elimination. Elimination is also called addition or solving by linear combinations. There's three different main ways that you can solve systems of equations. That's graphing, substitution, and elimination. Each of these methods has their own pros and cons. Graphing is good when we are dealing with equations that are in slope-intercept form, say y equals. Substitution is good when we have a variable that is isolated, x equals or y equals. Elimination is nice when you have your variables that have coefficients, aren't in slope-intercept. It works all the time, but it's nice when you're dealing with coefficients. The goal of elimination is to eliminate one of the variables. So in my problem that I have set up here, I have 13 and 4 as my x coefficients, and negative 2 and 3 as my y coefficients. So my goal is to try and find a number that my coefficients can both go into. It's kind of like finding a common denominator. So I'm analyzing. Do I want to look at my 4 and my 13 to make them some common number, or do I want to look at negative 2 and 3? My brain works a lot better with negative 2 and 3 than it does with 13 and 4. So I know that both 2 and 3 go into 6. And the nice thing is that my signs are already opposite, so I'm good to go. So what I'm going to do now is I'm going to move forward with the goal of eliminating my y variables. So I want to make my y's the same number with different signs. So the coefficient is the same, but they're opposite. So if I take my first equation, I'm going to multiply this equation by 3. I'm going to multiply the bottom equation by 2. And that should get us to our goal of having both of the y variables at 6. I distribute the 3 to each term. 13x times 3 is 39x. Negative 2y times 3 is negative 6y. 25 times 3 is 75. Bottom equation, 4x times 2 is 8x. 3y times 2 is 6y. Negative 14 times 2 is negative 28. And now I notice that both of my y's have the same number but opposite signs. I'm going to go ahead and add my two equations together. 39 plus 8 is 47x. Negative 6y and positive 6y cancels out. 75 and negative 28 is positive 47. I divide both sides by 47, and I get x equals 1. And now I take this 1 value and I plug it into either of my two original equations to solve for x. 13 times 1, because x is 1, minus 2y equals 25. I'm singly in terms of y, so I'm going to isolate y. 13 times 1 is 13. I'm going to subtract 13 from both sides, which leaves me with negative 2y. 25 minus 13 is 12. Divide by negative 2 on both sides, and I get y equals negative 6. So my solution is 1, negative 6. I can verify this by plugging that solution back into both of my equations to make sure it's true for both. So 13 times 1 minus 2 times negative 6 equals 25, maybe. That's 13 plus 12, maybe equals 25. And in fact, 25 does equal 25. That is true for the first equation. Let's double check the second equation. 4 times 1 plus 3 times negative 6 equals negative 14. 4 times 1 is 4. 3 times negative 6 is negative 18. 4 minus 18 is negative 14, which does in fact equal negative 14. So 1, negative 6 is a solution to my system of equations.